Welcome back, Math 32, Lesson 2 of Analyzing Rational and Radical Functions. So in today's lesson, we're just going to build up of what we did last lesson and look more into radical functions, okay? And we're going to investigate what does it mean or what happens when we square root any function, okay? So, just start off here. I'm going to start off your investigation with you and help you out at the very beginning and show you what it wants you to do. So we have y is equal to f of x, and then wants us to solve this and graph it. So let's see what it looks like. So f of x is x squared. So I'm going to put that in. We have, go up here, we have x squared. Okay? Then we want to square root f of x. So we square root x squared. And we're going to graph it. So I take a look, there's my graph. And it's pretty interesting in this area right here, isn't it? But I can't really see it. So I'm going to zoom in. I'm going to change my windows. Now we know it doesn't go, whoops, window, we're going to zoom in. We know my x is too big, so I'm going to maybe go between 5 and -5. Okay? And my y, there's no really y. It doesn't go below the y for this one. And maybe I'll leave it at -1. So I'm just going to graph and take a look at this now. Now take a look at it. That's a little bit more interesting, but still a bit blurry. So I'm going to zoom in a bit more. So my y max, I'm going to say it's just going to be 3. Now let's take a look at the graph. And I look at that, now it's interesting. Look at how this goes. Now, right here is the cutoff, or is it here the cutoff? Take a look at what's happening. I want you to write, what do you think the domain is, the range, and how are they affected? Well, looking at this, my range is still everywhere, right? My range is still positive. Okay, my domain still all negative, all positive. So my domain and range were not quite affected in this one here. So, but what does happen at these points? That's an interesting thing there. Alright, so I want you to think about that. So this graph kind of looks like this. It looks a little bit like that. So now let's try the next one. I'm going to look at x cubed for you. So we want x to the power of 3. So let's put this here, and it's to the power of, whoops, 3. Okay? And let's graph and see what this one looks like. But now this one goes below and above. That's interesting. It looks like this one only goes there. I'm going to zoom in and make it a bit narrower. Okay? Oops. Let's make it a bit narrower. So I'm going to go between 3 and -3. The graph. And the other one just starts from there and goes like that. Once again, there's a point where it changes, where it's above and then it goes below. Let's take a look. This one's going to look something like this. And I think it bends a bit. Okay? Let's take a look at my next one. We were looking at x plus 1. What does this graph look like? So put that in there. I'm going to have, whoops, y equals, we're going to look at x plus 1. So I'm going to clear that, and I have x plus 1. This one here, I'm going to clear what's in here. Clear, and we have x plus 1. And let's graph, see what it looks like. So there's my graph. Whoa, look at this. We are above, right here, and here we're below. So this is going to look something like this. So look at this. The domain of f of x here is x is an element of all real numbers. Okay? My range of f of x is y must be greater than or equal to 0. Now what about the domain for this one here? We're just looking at I. I'm just going to put a line down there. We have x is an element of all real numbers. Here we have y must be greater than or equal to 0. Okay, let's take a look at this one here. Well, for my original function, we have my y value. Y is an element, or my x, because we're doing domain, is an element of all real numbers. And my range is the same thing. It goes forever up and down. So we have y is an element of all real numbers. But now I look at my domain. My domain here changes. How's my domain changed? My domain is x must be greater than or equal to 0. Now my y is the same here. Y must be greater than or equal to 0. Alright? Let's take a look at my next one. I look at this here. We have domain of this. Well, my domain is x is an element of all real numbers. Okay? My range is, well, we're looking at y. Y again, it's going forever up and down. Y is an element of all real numbers of my original function. Now let's take a look at when we square root that function. Okay? Oh, it's the same thing. Okay, so let's take a look at when I square root that function. Well, my domain is right here. It must be equal to 1. So my domain is x must be greater than or equal to -1. Alright, and x is an element of all real numbers. My range is y must be greater than or equal to 0. So it's starting to look like my range must be y must be greater than or equal to 0. Now I'm going to just show you how to do these ones here and where the absolute function is in your calculator in case if you forgot. So if I'm looking at this one, I'm going to have to go math, go over to number absolute, and we have x. Down here I'm going to clear, go math, absolute, and I put in x again. Okay, now I graph, and here is my graph. So there's my first one, and then there's my second one. Well, isn't that interesting? So this is going to come in like that, and then like that. Well, that's kind of interesting as well. Okay, so I want you to do the domain and range for each of these, and come back at the end. Alright? So let's take a look now at question number 2. Alright? Now, the first part here, it says we want to change our window. So we want it, x min is -8, max is 8, and we have 1. Then we go from -10, then we're going to go 10, and 1. Okay? Now let's plug in my equations. We have x squared plus 4. So I'm going to put in x squared, and then I'm going to plus 4. Now we're going to plug in the square root of that exact same equation. So we're going to have x squared, then we're going to plus 4. Alright, now we graph it, and it looks something like this. Okay? So there is what my equation will look like. Right? So now I want you to do the same thing for these. Find the domain and range and how everything works. Okay? And also find the domain and range for those ones. So then pause, and once you're done, come back and resume the video. Okay? Now, I'm going to help you answer all of this here. So when f of x is equal to 0, f of x lies above, on, or below the line y is equal to f of x. This one here is going to rely on. It is going to be called an invariant point. The next one is when x is greater than 0, when the function is greater than 0 and less than 1. Okay? Now, we have the square root of f of x is going to be, so it's in between 0 and 1. So let's look back at these here. When it's in between 0 and 1. So on 0, they're the same, right? Right there, 0, 0, 0, 0, they're the same. But when it's in between 0 and 1, when my y value is in between 0 and 1, we are always above. Okay? So it is going to be above. Now, when f of x is equal to 1, what happens there? When it's equal to 1, they cross. That's an intersection. That is when they are equal again. So that is going to be when they are on each other, the graphs. Alright? Now the last one here says when f of x is greater than 1, well, every time we are greater than 1, and just these here, we could see, same with these here, we are under the graph. Okay? Greater than 1, we are under the graph, under the graph, under the graph. Even if we did this one here, this one kind of looked like that, where it's always under the graph. So it's always going to be below the graph, y is equal to x, the square root 1. Okay? So now, here's just some review for you to do and look at, and we're going to get into our first class example. So this one here states, sketch the graph y is equal to f of x on the grid. State the domain of f of x. Well, my domain of f of x is an element of all real numbers. Okay? Now, we want to state the domain of the square root. Well, right here, it's going to go like this all the way to here, because in between here, there are no answers. So we're going to have x must be greater than or equal to, this looks like negative 3, and it must be less than or equal to 10. All right? So now here we want to find the range of the graph. Well, this one right here, my range is, well, I have a max of 4, and then it goes down forever and down forever, because that's my original function. So y must be less than or equal to 4. That's my range, and y is an element of all real numbers. Okay, and y is an element of all real numbers. Y such that, we should be putting that for all these, but we're not. Here we should have x such that, okay, and x is an element of all real numbers. But now let's take a look at this one, the square root. Well, I can't square root the negatives. So I look at this, we're going to have 0, right? Y must be greater than or equal to 0. We're looking at y such that y must be greater than or equal to 0. But also, my max is 4. But that's when f of x is 4, and if you square root that, that's going to be 2. So that is my, and y is an element of all real numbers, so that is my y, my range. Okay, that's my limit of my range. Now it wants us to graph this. So all the way, this is going to be 1. It's going to look like this graph. And then it's going to go below till we hit 2. Where it's there, it's going to be like 2, all the way across to there. And then it's going to go like this again, still stay below, till we hit right here. These are my invariant points, so I should label my invariant points right there. So then, now, it's going to look like this. It's going to be above. We have another invariant point here, and another invariant point there. It's going to stay above, hit that, right? And then it's going to be just above, below the thing. Then we go till we hit my invariant point. It's going to go look like that. So that is kind of what my graph is going to look like. And this graph here is y is equal to square root of f of x. Okay? Hopefully you get that. Let's take a look at number 2. It says, in each case of the graph, g of x is shown. Okay? If h of x is equal to square root g of x, determine the domain and range of h of x without sketching the graph h of x. So I want to determine the domain and range of this. Okay, so we take a look at this. Here, my domain. Well, it goes forever this way and forever this way. There is no minimum for this, right? So I look at that. There is no minimum. It doesn't go below 0. So my domain is x is an element of all real numbers. Now let's take a look at my range. We're going to be looking at y. Okay? Now, y goes forever up. But my minimum y is 3. Okay? So y must be greater than or equal to the square root of 3. Okay? And there is my y. Okay? And y is an element of all real numbers. Okay? So let's take a look at b now. We look at this. X can't, for my square root, my graph is going to be in between here and here. This part here is a no-go. Same with this part here. So my actual domain here is between this one and this one, right? And between this guy and this guy. That's the only places where my x could be. So my domain for h of x, which is the square root, is going to be, we're going to have x, we're looking at x, such that, now it must be greater than negative 3. So we have negative 3, x must be greater than or equal to negative 3, but less than or equal to 2. Negative 2. It's in this area here. Okay? Also, we know that we have x again. It must be in between 3 and 8. So we have 3 and 8. Okay? And we're looking that x is an element of all real numbers. Okay? So there we go. Now let's take a look at my range. Now, this part here, we can't square a negative, so that's out. So my range is from here to here, and then here to here, and we don't have those there. So my range, we're looking at y, such that, well, square root of 9. So it's going to be between 3. So we have my range is right here. Y is between 3 and 0. So we have 0, y, and 3. And this part here is within there, because this is 2. 2 is within this 3. It's just right there. So that and y is an element of all real numbers. Okay? So that is how we do this here. Hopefully you understood. If you have any problems, come to me in class tomorrow and we'll work on this together as a class.